if you were looking at a problem like this and they say, hey, what's the average value, right? You guys got to remember the average value of a function is just this equation right here, right? You remember the equation for the average value? What's it equal to? 1 over b minus a, integral from a to b. Perfect. Right? Now they're telling us to do it without integrals, which means that they don't want us to do the antiderivative of it. But do you guys remember what exactly are you finding when you find the the integral of a function?
The area.
The area. So when they say to do this without doing the integral, they're kind of just asking you to calculate the area of this, right? So what's my a to b in this problem?
Negative 4 to 2.
Yeah, so it's going from -4 to 2. I want the average value of this. All you got to do then is still do this formula. So it's going to be equal to 1 over -4. Wait, that's wrong. What's your b in this case? 1 over 2 minus -4 times this thing right here. But this is just the what? It's just the area from here to here. What shape is this? How do you find the area of a triangle? Yeah, so this is just going to equal to 1/2 base times the height. Right? Yeah. Yeah. So, what's your base in this problem?
6.
Yeah, so the base is 6. What's the height?
2.
3. The height is 3. So we just plug that into this formula. So we end up with 1 over, looks like 6 right there, yeah? Times 1/2 times the base, which is 6 again, times the height, which is 3. And that's your problem in a nutshell. That's it. The average value for this problem, it looks like it should be between 0 and 3. Would you agree? Yeah. Right? The average should be between 0 and 3, which comes out to be the 6's cancel right there. We're left with just 3 over 2, which is what? 1.5. So if you had a cup filled with strawberry Nesquik in a pyramid shape, like that, nice, right? Filled with a cup like that, and it made this shape. If you were to shake that whole thing around, right, shake it all around, it would balance out to about what value? So instead of being all the way up here at 3, it will balance out at not 1, not 2, but about the halfway mark, which is going to be right about there. Which kind of makes sense, doesn't it? If you flattened it out, the powder would level down to there to about 1.5. Yeah. And that's your answer for that one. Does that make sense? So on your homework for 5.3, once you get past number 17 on there, 17 asks you to do the same thing using graphs instead of using the integral. You kind of try to see it out. Number 17 is a similar problem, except the function they gave you is sine, and they're asking you to calculate the average value from 0 to 2 pi. Let me go ahead and show you that real quick. I'll give you a second to copy that down, though I see some of you are still writing, so I'll wait a little bit, because this is one of your homework problems.
So Nesquik equals 1.5?
The level of Nesquik equals to 1.5, yes. The level it levels out at. If you were to shake it around, it shakes out to 1.5. Okay, you got it?
Oh, can I show you something?
No.
Oh. Okay.
What are you trying to show me?
Oh, my phone. He has my phone.
What?
He has my phone.
Oh.
He's getting his quote in.
Ah.
Oh.
Nita, you still writing or are you good?
I'm good.
All right.
Wait, can I?
Get it set up while I write. Get it set up while I write. So number 17, I believe, had the average value for f of x is equal to sine of x, I believe, right? Yeah. Given on the interval from 0 to 2 pi. So again, you could do this using integrals, right? But the directions tell us to do it without using integrals. They want us to do it just by looking at it. Did you set it up?
Yeah. Wait, so if you do it with interval, you get the same answer?
Yes.
Oh.
Yeah, I saw that. Now you just see them everywhere, don't you?
Yeah.
Math memes. All right.
Oh, yeah.
So if you do this using integrals, right, how do you find the average value?
But 1, 2, 5,
Yeah.
0.
Good. So it's going to be 1 over 2 pi minus 0 times the integral from 0 to 2 pi of sine of x dx. Yeah? What's the antiderivative of sine of x?
Negative cosine.
Negative cosine. Why is it not just cosine? Yeah, derivative of cosine would be negative sine, which does not match with what we have here to start with. Does that make sense? So the antiderivative of sine is cosine. So I would have here 1 over 2 pi times negative cosine of x evaluated from 0 to 2 pi. Right? They told us not to do it this way, by the way.
Yeah.
I'm just doing it this way because I'm trying to prove a point. But check this out. Did you know that cosine of 2 pi, do you know what that value is?
Oh no, I don't want to remember this. Is that just one?
It is just 1. So it's going to be negative cosine of 2 pi, which is just going to be a 1, minus negative cosine of 0. Do you know what cosine of 0 is? It's just 1,
Wait, but don't you have to put the negative in front of it?
which there's 2 negatives there.
Yeah, don't you have to put like -1 minus -1? Just cancel
Yeah,
out. Oh.
they're there. I got that negative sign there, and I got that negative sign there, right? And I'm subtracting the 2 of them, right?
You forgot a parenthesis.
Did I? 1,
Or is
2.
it just, oh, never mind.
Yeah, I think it's okay.
Yeah, I'm checking.
So when you plug it in, you get 1 over 2 pi times negative 1 minus negative 1. That's just going to be 0, isn't it? So the average value for the sine function from 0 to 2 pi is 0, which means that if you flatten it out, it would just flatten out at 0. Now, I'm hoping that kind of makes sense, because if you think about a graph of sine, what does a graph of sine look like? Going from 0 to 2 pi. Yeah, it does this, right? It goes up, down, and comes back here. So we're going from here to here. What's the average value of that, if you think about it? It'd be 0, right? If you average it out, you have some above and some below, and it's the same amount above as the same amount below. It comes out to 0.
See, thinking about it like that makes sense, but I thought of the negative, and I'm like, how's it just gonna be?
So that's the problem with the Nesquik example, because Nesquik, everything's positive, right? It's a powder that's everything above the part right here.
What if
So-
you put it below sea level?
So that's the thing. If you think about these negatives, it's just that it's moved down a little bit. So if you move it up a little bit more and you level it out, it'll just level out to the middle of that. That's what that is. But yeah, 0 is just a position if you think of it that way. All right. How do you feel about the average value theorem? How do you feel about integrals?
Except when they ask you to find B and A, so like on the homework it gives you like 5, 0, and then just f of x equals, and it gives you.
Okay,
A.
we can talk about that.
But then you find the interval and it's completely different. Like
Okay. So let's do an example of that real quick. Let's say they give you this, right? Properties of integrals, by the way. What's up?
Question, so let's say like the problems asking you to do without intervals, you do with intervals. Is the point taken away or?
This is homework, so no.
Oh,
On the test, they're not going to ask you a question like, do this with just the area. They'll give it to you in a way that you won't be able to do it with integrals. And we'll do that today. I'll show you that. But let me talk to you about properties real quick. Properties. Is that how you spell properties?
Yeah.
Yes?
Not me.
Oh, it looks like one of those things from like
Is that better?
oh, what are those things called? From Disneyland.
All right. So
No, never mind.
let me give you some example here. Sometimes the homework will give you something along the lines of like, yo, hey, the integral from 0 to 5 of a function is equal to 6. And then they'll go along and say, yo, you know what else is there? The integral from 0 to 3 of a function is equal to 2.
this was the first problem.
Yeah. Sometimes they'll also say, yo, hey, the integral from 0 to 5 of g of x is equal to 12. Why 12?
I don't. Me either.
So they might do this for you. So they did the integral for you on these intervals, and they give you the answer. The area underneath the f function from 0 to 5 is 6. The integral from the area underneath the f function from 0 to 3 is equal to 2, right? So they'll ask you something along the lines of, yo, can you tell me what's the integral from 5 to 0 of f of x dx?
I understand that.
And that's going to be negative 6. How'd you know it's negative 6? Yeah, the directions got switched for this one right here, isn't it? That one's not that bad, and most of you are like, yeah, I get that one. That's good. You understand that that is a property, right? That is a property. You also understand other properties. For example, what if I told you, hey, what's the integral from 0 to 5 of f of x plus g of x dx? 8. Yeah, and it would just be 18. No, not f of 5, it would be integral, the area underneath f of x plus the area underneath g of x, and we just add them together. What if it was minus? You subtract the two of them, yeah? I think the hardest property that people forget about is when they ask you, yo, hey, what's the integral from 3 to 5 of f of x dx? What do you think that's going to equal to? Is it what? Could be.
Wouldn't you do that? I don't even know how to type F, capital F.
We don't have the function to do the capital F. You're overthinking this. Look at the intervals. What intervals are given to you? 3 to 5. Oh, no, 3 to 5 is what we're looking for, right? What do they give you? They give you 0 to 5, and they also give you 0 to 3. So guess what? Did you know that if you add intervals together from 0 to 3 of a function, dx, plus 3 to 5 of a function, you know what that totals out to? 0 to 5 of that same function.
Oh, yeah.
Remember,
Would this be considered C?
remember,
Oh, I see. You're adding intervals.
remember, let's just say I have some random function. Goes like that, right? Here's 0, here's 1, 2, 3, 4, 5. So there's 3 and there's 5, yeah? If I did this right here from 0 to 3, would you agree that that's this area? Right there. Thank you for not spoiling it for those who already see it.
Oh.
What does this one do? That gives you the area from here to here.
Oh. Okay, that makes sense.
Wait. Shh. No. Pretend that you don't understand it yet until I finish coloring it all in.
I don't get it now.
Yeah, I know. It's kind of hard to see until you see it. There. Okay. Now, what's this last one? Why, that's everything, isn't it? Which is all the way from here to
Nagi, what do you? You keep going.
What do you know about this one? Why, that's all the way from here all the way to here, isn't it? Oh, that's a terrible highlighter color.
On the outside.
It's okay. Just
Okay.
So, if I'm asking you, what's the integral? Look, just let it happen. What's the what's the integral from 3 to 5? If I want you to find this for me, don't you already know what the red one is?
Yes.
This red one is what is equal to what?
6.
That's equal to 6. What's the yellow one equal to?
2.
2. So what's the missing part?
4.
Ta-da!
Wow. Wait, how's the missing 4?
Oh, because it's going by 2.
So
Six, yes.
is that do you need me to show it, or are you okay?
Get it now.
Yeah?
You minus it to the other side.
Yeah. So little pieces like that. They're gonna do that, by the way. I should have shown you more practice on that. But does it make sense though?
Yeah. Looking
Yeah.
back on the notes, that's not going to make sense. It's red and black.
Look, just like like
I've done the haircut.
wait, I figured it out. Hold on. I think I figured out what colors to use.
Blue.
Okay, hold on. So if I do yellow, right, and I do green, they just overlap. So that's not going to work. But if I do yellow and I do blue, they overlap to green. So what I should have done was I should have done yellow here, from here to here, like this. Right?
Wait,
Right?
yellow and green
All right, should that work?
Make a color?
All right, like that. Yes, 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 yes. And then do blue for here to here. All right?
No.
No? It's not gonna work?
No, overlap. Are you gonna use blue to overlap then the?
Oh, that's not gonna work either.
Other side's still gonna be blue.
Oh, so what should I pick?
Wait, test it out. Does
And then-
blue
and then-
overlap on green?
Yeah, but.
And then if I do green,
Blue is
ah,
green.
yeah.
Overlap it like that. Why don't you like do like
Yeah, so then this one's green.
Just let it happen.
Look, see? See? Both of them together make green. Haha.
Please.
Actually understand.
Welcome to calculus, where we discuss what colors should we use on our notes.
Where
We're
we
gonna
waste
argue.
time on precious learning.
All right, so that's all that stuff. Are you okay with that? Because I'm going to move on to the last section for today.
New notes?
For today.
For today, I meant for this section, or for this chapter.
I was gonna say, it's 3 notes then.
Yeah, let's check out.
5.4,
Y'all didn't have to create a site for the today part.
trapezoidal
Oh, okay.
rule. Longest unit.
This is the last part.
This is the last part of 5.
Oh, dang,
Unit
we have a
5.
test.
Unit 5 is a short unit.
You trying to give us a
Hey, we have a test.
I'm so confused.
Don't we have to get through 8 units?
Yep.
We're not gonna do
I
that.
want to say 7 is probably the longest, if I remember correctly. I should know this.
Are we
We're
gonna
not
get there?
gonna do that.
We're not gonna.
Yeah, we're gonna get there.
Can't get
We
through
literally have like
3.
2 months.
Yeah, we're gonna
This month
we're
we get
we're
through 6.
finishing 6 before we go on spring break.
What?
I can see that. How can I make that?
I'm honestly not sure for this unit.
Don't
I know.
be surprised 'cause in
And we'll
college
finish
goes
it.
faster than this.
All right, here we go. So, let's say I have a function
Nothing.
that looks something like this, right? Some random function f of x, right? And if I wanted to calculate the area underneath it from a to b, we found out that we have this neat little tool called the integral, right? And you do the integral of that function from a to b, it gives you that area. Now, you have to remember though, that came from a nice tool, didn't it? It came from a nice tool that we called RRAM. Yeah, or if you want to call it, Riemann sums is the official name of it. Riemann was this guy who was like, just use rectangles. And we summed up all those rectangles, and if there's infinitely many rectangles, it approximated pretty well.
Was he white?
Yeah. With a name. But, yeah. Now, no, I mean, it's no longer February, so let's keep going. So,
Oh, you're done.
all right, here we go. All right, here we go. So,
I hope they heard that.
About Kepler enough?
Because back to 3 months is over.
all right, so
We're gonna cancel that.
whoever that is. So, focus. So, when we do RRAM, I would ask you to give me a specific number of rectangles, and then for RRAM, we always use the right side of that rectangle, yes? So, I just drew here a crap ton of lines. I don't know how many rectangles that is, but if I was using the right side, I'd start from here, work my way over, and go like this. Something like that, right? Is that okay? Boom, and last one right there, boom. So that's our RAM. Yeah, and we calculate the area of each of these rectangles, and we'd sum them all up. Yes? Now, that's all well and good, but with our RAM, you kind of lose some area, or you might overestimate some area. In this case, I think we're overestimating, right? You see it? A little bit of overestimation right here, a little bit of overestimation right there. Yeah? LRAM would be a little bit better, right? LRAM, right, if I did that in, let's say, pink, LRAM would be on the left side, and it would go across like that, wouldn't it?
Yep.
And it'd be a little bit less, but it still wouldn't be that bad. Yeah. There's one more as well. The last one, which was middle RAM, mid-RAM, MRAM. MRAM, I'm going to zoom in a little bit, gets exactly in the middle of it and goes across, where it does a little bit of overestimating and a little bit of underestimating. Yes? Those are the 3 ones that are usually covered, but there's one I guarantee you that they'll always have on the AP exam in some way, shape, or form. And this is today's lesson, which is the trapezoid rule. Using trapezoids is actually going to be a little bit more accurate than both LRAM and RRAM combined. Trapezoid rule is exactly this, right? So if I took the same graph, let me see how well I can redraw this. Yeah, I was doing fine until somebody talked. Hey, look, it's so much better when no one talks. All right, so we. I'm sorry, I'm cranky today. It's not your fault. It's my fault. I don't know why I'm cranky.
I am too, actually.
Yeah,
Brandon, I can see it on you.
I think I'm cranky because I have to teach all of you.
Yeah.
That makes sense.
No, it's fair.
No, it's not fair. That's
No,
not
no, it is.
No, no, never accept that.
You don't have to.
You have to realize that I actually enjoy being here. I enjoy teaching you.
You really?
Okay? Yes.
Just because you enjoy teaching doesn't mean you enjoy teaching us. There's a difference.
I'm sorry.
Dude, why are we like slamming ourselves? Like,
Okay. So focus here, real quick. So same thing here. What do I have here? 1, 2, 3, 4, 5. So if I had here 1, 2, 3, dang it, 4, 5. Ugh. 1, 2, 3, 4, 5. There we go. Okay, so check this out. Instead of doing LRAM, RRAM, and MRAM, I can use a trapezoid instead, where this part right here is still going to be delta x, right? If I zoom in really close right here, that's still going to be a delta x. That's the width of each of those rectangles, okay? I'm going to do the same thing here. These are still also going to be delta x's, right? But that delta x is not going to be the width of a rectangle, of a trapezoid, because when you think about trapezoids, we don't have widths. Check this out. You ready for me to draw this out?
yeah.
If I go up here, the way the trapezoid works is it uses both values on the left side and the right side. It uses the R side and the L side, and instead of drawing a rectangle, it just connects the two of them. And when it connects the two of them, it makes this upstanding trapezoid, right? The trapezoids are normally drawn on their sides like this, right? That's terrible. Shh, shh. Let me. Uh-huh. Now you know, right? So check this out. The delta x is actually what the height is. You see that? It's actually the height of the trapezoid. Do you see it? If you tilt it sideways, right? And I drew these lines like this. Yeah? Now, the R side, which is right here, would be your base 1, which is equal to the R side of your trapezoid. Base 2 would be the top side, which is your L side of the trapezoid. So this is B2 and this is B1. So the only hard part about the trapezoidal rule is not the picture, right? You understand the drawing of this. Does it kind of make sense? Right? It's just a trapezoid standing up instead of sideways, yes? I'd say the hard part about this is remembering the area of a trapezoid. 1/2 times base 1 plus base 2 times height. It's a mouthful to remember it that way, but we were forced to memorize this back a long time ago, not for you, but for my generation. We did have to memorize these equations, and it actually, I think, makes more sense if you just try to understand the equation. So for example, right here, if you think about it this way, I think it's a little bit easier. You're taking the average of the bases and multiplying it by the height. And that's how we're calculating this area. That's the reason why it's 1/2, and then you add the two bases together. You get the average of those two, and it's kind of like, does that make sense? And that's what we're doing here. So, because it's not a perfect rectangle, yes? So we take the average of the two and then just multiply by that height. There's a whole visual on this, but that's how I remembered it. Just think of that as the average of the bases, multiply that by the height, and you get the area. Does that make sense? Some people prefer remembering this equation instead. B1 plus B2 divided by 2, because again, that just is an easier way of representing average, yeah? Since we're working with the theme of averages.
Yeah.
Is that okay? Does that kind of like make sense or not make sense?
Yeah.
So, yeah. Why am I showing you this instead of just doing LRAM, RRAM, and MRAM? Is because on the AP exam, I've always seen trapezoid show at least once. And you'll say, well, then why not just do trapezoid and just skip LRAM, RRAM, and MRAM? Every now and then they'll throw that in there as well. So just kind of cover your bases here. Make sure you see a little bit of each. But they're all the same ideas. You're just calculating areas. Yes?
Could you say that with the trapezoidal ram, I guess,
Mm-hmm.
you get like, you could get the total area,
You'll get very, very close to it.
so you won't get it.
Exactly, no. Well, it also depends on how many trapezoids you have. If you have infinitely many trapezoids, it should be just like infinitely many rectangles. It should be perfect. Will it be perfect? If you get infinite, yes. If you get 100 billion, you'll be off by 0.000000001. But yeah, close enough for some people. All right, let's do an example of a problem.
Wait,
Okay.
can I take a picture of this real quick? 'Cause I'm
Mm-hmm.
not very
Mm-hmm. Mm-hmm.
Thank you.
You got it?
Yeah.
All right, here we go. For these ones, what they like to do, all right, let's do a problem here. Let's say I have here some table values. Let's say I have here x on the top part and f of x on the outputs. So let's say we have some values here that goes from 0, 1, 2, 3, and 4. And the output values for these are going to be 5, 7, 4, 6, and 5. We're going to try to approximate. Is that a P, knock me? The area, or let's say the integral from 0 to 4 of f of x dx. So here's one example, right? I cannot do the antiderivative of this because I do not know what the function is, right? I just know that the output values of those functions are there. Well, right, so if I really wanted to do this, I wish I could just do like, just do the antiderivative of this, right? That would just be capital F of x, and then evaluate that from a to b, right? But we can't do this method. I don't know what the function is. I don't know if it's sine, I don't know if it's x squared, I don't know if it's 3x. And it's actually a lot harder to find the function just by having only 5 points. So we're going to approximate this answer by either using LRAM, RRAM, or MRAM, but for today's lesson, let's do it using TRAM?
I like that.
TRAM.
Like the ones at Universal Studios.
So,
It makes me think of Lady and the Tramp, like,
Why you
one
not?
side, like,
Stay over there.
he's a tramp. Ba-dum-bum,
Stay over there.
ba-dum-bum,
Hey.
from the original movie?
Yeah.
Oh, yeah, yeah, when they're in the
When
pound.
They're in the pound, yeah.
Yeah, I forgot that song.
You too, but
All right, help me out here. I'm going to go ahead and draw this out. Now, when you do trapezoidal rules, you don't have to draw it out. I like drawing it out because it makes it easier for me to see the bases and the heights. Okay? Now, check this out. When x is equal to 0, right, what's y equal to? Yeah. 1, 2, 3, 4, 5, 6, 7. It looks like it's the highest it's going to go to. So at 0, it goes up to 5 right there. Yes? And then it looks like the x's change along here by 1. So 1, 2, 3, 4. So what is the value at x equals 1? We get 7. When x equals 2, we get 4. When x equals 3, we get 6. When x equals 4, we get 5, which is right there. Can you see the function?
oh, it's not.
Now, I don't actually know if they're jagged like this, right? I only know the dots, right? So it could actually be something like this. It could be like that, right? It could be for all I know, going up here and then coming down here and then going up like that and then coming down like that, right? I don't actually know, okay? And that's okay. That's why we're doing an approximation. I don't know if it's going to be way high or way low, so our approximation is just going to use some rectangles. Don't draw this next part out. If I decided to use RRAM, I would make rectangles based off the right side heights. Don't draw this, please. So you see the RRAM here? That's my RRAM, and that would be my estimate for that. That's how RRAM works. LRAM is the same thing, except you just go from the left side. Okay? Today, though, we're using tram. So, you ready for this? Do you see the first trapezoid that I can make on the far left side? Boom, boom, boom. Do you see the first trapezoid? That's this one right here. So, to calculate the area of that blue trapezoid, it's going to be 1/2 times base 1 times plus base 2 times the height.
Do we draw the blue trapezoid?
Please draw the blue trapezoid. So, what's B1 equal to?
It's
5. Do you see it? The base of this side of, I know it sounds weird because of like knock me, that's clearly going up and down. But remember, this trapezoid is standing upright. Yeah, rotate it. And that's base 1, which is on the top right there. Plus, what's base 2? It's at 7. It's at 7. I'm sorry, it's at 1, which is 7. I just gave it away the wrong way.
the height's 1.
Yes, that's it. That's it. The height is 1. So again, if you don't remember this formula, don't worry, right? Area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. And the height in this case is right here, from here to here. That's your height, which is 1 in this case. Is that okay? Go ahead and do the rest of them. Draw it out. See what you get for each of these ones. I'm going to color code mine like this, okay? I'm going to do this next one red. From here to here. Give me that area. I'll do the next one after that purple. From here to here. And then I'll do the last one in green because green is not a bad color. Jasmine, what's up?
Okay, so when doing base 1 and base 2, does it matter which is your base 1 and base 2?
Not at all. If you keep them in the consistent spot, though, you'll see a pattern. But we'll talk about that later. But yes, it does not matter. Because 3 plus 5 is the same thing as 5 plus 3. Would you agree?
I'm so happy that's happening.
You might have to solve it and just have the formula.
A little bit of both. How far can you go? Just see how far you can go. Oh.
That's why it's stuck in my head now.
When you get old, random things just pop.
The other day, oh my god, I danced for like over 10 years, right? And the other day, I had to stop dancing because of my knees and all my bones were like dying. So, and then the other day I was talking with my siblings, and my sister asked me if I could still do like one of the turns,
Oh
and I tried
no.
doing it.
Oh no.
Every single bone in my body popped so loudly. It was so bad. I felt so bad. I was like, I used to be able to do this like.
But did it not feel good?
Huh?
It didn't feel good?
No, it hurt.
Oh.
Not me. Have you watched Batman?
Not yet.
Like when you
No?
I will, but it's not yet. Wait, listen. Shh. Ready? I don't know if I can get it pop. No.
You've done
No,
it.
you've done it.
Green, bro. I thought you were about to get green.
That one did.
Man, I'm
It
gonna be
could-
cool.
you can kinda hear it.
This one doesn't want to pop though.
So sometimes I'll just stand up and my knees will pop.
Oh.
How
That's
old?
You're not that old. That's
Huh?
You're not that old. You should not be popping.
I'm old.
My body aged a lot quickly.
I'm old.
Yeah, my knees are a
They
good
don't
60 years
move.
old. Honestly, I have such bad knees.
My leg.
Volleyball has really messed up my knees.
So, here's the thing. You think you're old. When you get older, it gets worse. With whatever joints, pains, or whatever you have, they just get worse.
I think the
Oh.
most painful
I think we all
joints.
have like.
I think my most painful joints right now are my hips, especially my left one.
I'm pretty
That's not
sure
good.
I have arthritis.
Yeah, like it's like when I approach, I have to approach on my like ball of my feet instead of like my whole foot, because then I'll feel the pain like go from my foot and it'll shoot all the way up to my hip. No, it's just because my hip is like super duper tight. And I
That
feel
sounds
how to stretch my hip, so
that sounds not fun.
it's not. But you know, You live and you learn and make
Don't
provisions.
miss that.
Smart.
Life sucks, you know.
I have to get tested to see if I have arthritis or not.
I can see that right
Oh,
now.
you should
Yeah.
just find that out early.
I don't want you to
Huh?
test the problem.
I can get tested.
All right. So, did you guys get these values here? What's the
So drawing my rectangles.
7 plus
Oh, I finished.
7 plus 4.
7 plus 4 times 1?
Correct.
This one over here should have been
4 plus 6.
4 plus 6.
No, who got these calculators?
Who what?
Boots with the fur.
Who's with the fur?
This is why it's important that you reset them every time you use them, because you never know what stuff could be on there.
Let me see. That's
6
like
plus
how
5.
I need to take a picture of that.
So, that's pretty much the trapezoid rule.
That's iconic.
It is
You do each one of them and you just add them all up.
Oh, that.
But, check this out. If you notice, some of the numbers get used twice. Did you pay attention to that? And it kind of makes sense that some numbers get used twice, doesn't it?
It's probably the one on the left.
For the first trapezoid, I use these numbers right here, don't I? To give me these values, right? And then the difference to jump from 1 to 0, or sorry, from 0 to 1 is just 1, yeah? And then I do the same thing for the next trapezoid from here to here. But then that jump from here to here is also 1, isn't it? Which are your delta x's, by the way. That's what delta x stands for, is how much is it changing in your x values, right? Do it again, go from here to here. That uses those numbers again, and it jumps here from 1 to 1 as well. And then the last one right here. So can you kind of visually see what numbers are being used twice?
Yeah.
It makes sense, right? They're the ones in the middles. You see that? Like right here. Right here. Look at this 7. It gets used over here as well, doesn't it? What about this 4? It gets used over here as well. And what about this 6? So all the numbers that are in there kind of get used twice, right? So this is the part that I kind of need you to see here. So the total area, by the way, we don't know the answer, or unless someone did already. Did someone get the answer? 22? Total area, when you add these all up, it equals to 22.
5
Is it?
times 3 is 15, 21, 22.
22. So, ready? Check this out. You don't need to write this last part down, but I just think this is neat. When you do this total area, you're just essentially adding these all up together, yes? This one plus this one plus this one, right? So it's 1/2 times 5 plus 7 times 1, plus 1/2 times 7 plus 4 plus 1, plus 1/2 times 4 plus 6 times 1,
Oh.
plus 1/2 times 6 plus 5 times 1. This is the part that I find kind of neat, is if you're just adding a bunch of things that are being multiplied by the same thing, do you know that all these 1s can be factored out because they're all just multiplying by 1, right? So it's a common factor of 1. And at the same time, these 1/2 are all common factors as well. So you could factor those out. I'm going to factor out all the 1/2 to the front. You ready? I'm going to put all the 1/2 up front. What leaves me behind inside is going to be 5 plus 7, and then I'll factor out the 1 to put at the very end. So I have 5 plus 7 plus 7 plus 4 plus 4 plus, that's a 6, sorry. 6 plus 6 plus 5, right? All, of course, being multiplied by what at the end? So this is one group, this is another group, this is another group, this is another group, and I just factored out the stuff that's around it, yeah? What somebody noticed is with the trapezoid rule, is every number in between, not including the endpoints, repeat themselves. So somebody decided to write out, well, could I just write this out as 1/2 times 5 plus 2 times 7 plus 2 times 4 plus 2 times 6 plus 5. So this is not necessary. This is just me trying to show you shortcuts. And I promise you, like, you do not need to do it the way I'm writing it out. You're perfectly fine doing this right here and getting the answer and just calculating it all the way through. You'll come across these people, though, once you get to college. You'll see somebody who comes up with techniques that make it so you don't have to write it out as much. And this is one technique that I've seen a lot of people who learned the trapezoidal rule. I never learned it myself. I never really focused on it, but I feel like I should show it to you so you're not like, what the heck is that? You ready? Some people realize that it's just going to be 1/2 times f of x sub 0, meaning your initial starting point, right? Plus 2 times f of the next x value, plus 2 times the f of the next value, plus 2 times the x of the next value, and then the very last one, plus it by itself, because it's not two of them. And then all of this, of course, is being multiplied by whatever your delta x is. So yeah, I met some people who said, oh, we got to do the trapezoidal rule. And they had a program written out that would double all the numbers that are in the middle here, sum them up with the numbers on the outside, and multiply by the delta x's all the way across. And they got the answer of 22, which is what we got. But again, do you need to do that? No. Yep. So in this case, there's how many trapezoids? 4 trapezoids. And sometimes they'll ask for 8 trapezoids or 6 trapezoids, or they don't even ask you for a specific number. They instead just give you a random table. And from that random table, you can calculate the number of intervals based off of how many they give you. Right? And I'll show you that right here. Anita, then Esther.
No, can you go down?
Anita?
Yeah, my question is Steven's question, but also, why is it only a 2? Like, is it because of the base?
Yeah, the base is being used only twice. We're not using it again and again, right? We're only using it for the trapezoid. For the blue trapezoid, for example, that 7 gets used for the blue trapezoid, and the 7 also gets used for the red trapezoid. So that's why it's 2, because it's being used twice. That's the only main thing. But is that okay? Do you need to know all this? No, no. But you do need to know how to calculate the area of a trapezoid. I'm perfectly happy with this. Does that make sense? Some people like this, and I don't want to say that they're crazy, but they are smarter. So I don't know what the heck it is. Maybe it's a little bit of both, that they're smart and crazy. I don't know. It's up to you. Yeah. All right. Let me show you a problem that would have different delta x's. So this one, you notice all the delta x's are by 1s. You see it goes 0, 1, 2, 3, 4. It doesn't have to be that way. It could go by any random number that you want. So for example, let me get to this one right here. Can you guys see that okay?
Yeah, you're right.
I would write this down.
I'm going through right now. It just pops up.
Nakui, do you know the answer to the thing I showed you?
No. You just plug in.
Have you ever tried?
You just plug it in the calculator. Let them do it for you.
Right. No.
So you're right out the whole thing.
I would. Select values of f of x are shown in the table below. What is the trapezoidal sum approximation for the integral from 1 to 11? Huh, isn't that so nice of them to give us the values from 1 to 11 as well? Using 5 subintervals as indicated by the table. What the heck does that mean?
I miss integers.
That equation that you gave us last time, we could do this instead of being 4 of the vectors? Plus them.
Yeah, there'll be 5 of them. Or 6. I think there'll be 6 of them. Yeah.
Oh, yeah.
But only 4 of them would be doubled. For the formula of a trapezoid?
I feel like elementary school and middle school set me up for failure.
Why?
Because like I was always like on all of my notes, like it would always be like Esther is like a model student. Esther is like ahead in everything. Especially in math. Like I saw one the other day, it was like it said that I was ahead in math.
Uh-huh.
And now I'm just dying.
No, ever since they switched to that, what was it, the Common Core?
Yes,
math
that was it.
stuff?
That's when I knew my life was gonna be hard.
I was all like, there's no reason for this. Why are we doing so much work for something that can be solved so simply? Like the way they do division now, it's so weird.
Literally,
So,
you were solving
check this
2
out. I learned multiplication this way. right? If they told us to do 22 times 8, they told us to do this thing, right? Where it was like 16 carry the 1, and then it'd be like 176. Shh. I know you're all angry about this, but hear me out. Hear me out. Right? You guys got taught this way as well, yeah? But then they started switching to Common Core. Now here's the thing. Here's the thing that tripped me up. I realized I was really good at math after high school. Now in high school, I thought I was kind of decent at math. I started was doing this stuff, and I didn't even care for mental math. I just plugged in the calculator because I didn't really care about doing 22 times 8, because that's not real math. That's just arithmetic, right?
Mm-hmm.
But here's the thing. You end up meeting people who do 22 times 8 in their head, right? Because that's just how college is. You'll meet people from all over the world, and you'll even at like any college you go to, you'll meet people who are smart. And that's the thing. You're like, I'm also smart. I can hang with these people. And then you come across people who can do, now this isn't even that bad. 22 times 8, you can do it eventually pretty quickly. But when you meet people who do this stuff like in an instant, none of them do it this way. And in fact, when I played a game, I don't know if you guys have seen this, they just brought it back on the Nintendo Switch. It's called Big Brain Academy.
Yeah.
Have you seen that game?
Yeah.
Big Brain Academy is this like fun, like fast game. Like they give you like a puzzle and you just have to solve this puzzle as fast as you can. One of the puzzles on there is like, what's 7 plus 3, right? What's 5 times 10? And when you get further along, they'll ask you to multiply large numbers. And when I got to this part where it was like, what's 22 times 8? And I started doing it this way, I ran out of time. So I wanted to get a faster time. So I wanted to figure out how could I do this a lot quicker. What came to my mind is exactly what they're trying to teach Common Core. So, and every single person I met, when I talked to them, like, what do you do when you multiply? No one does multiplication this way except for people who learned in the United States. When you meet people outside of them, they do different things. Like, for example, I had the way that I ended up shortcutting this was I would do 20 times 8 and then 2 times 8, which is the same thing here, but for some reason I could do that a lot quicker than carrying the 1 and adding to it. It is the weirdest thing.
160.
Yeah.
16, yeah.
So that, I know it's like, yeah, why don't they teach us this? They do. They teach it to you as the distributive property. Which, by the way, is exactly what's happening here. You're doing the distributive property, but they're giving you this organized way. So when they teach you Common Core stuff and it looks different, it's because they're trying to teach you the way that's actually more natural than this. This feels natural because they drill and kill this into you, meaning you do this for like hours on end until you get it right. Yeah? And then you have a process now, which is not bad because you have a process to do it. But when people start talking about Common Core, sit back for a little bit. The people who are complaining about it are the people who don't do math different ways. And they'll feel like, why do it this other way? Those are the same people who are like, wow, have you seen the people in Japan? They multiply by drawing lines out, and then they sum them up with the dots, and that's so cool. But yet you want to crap on Common Core when this is also Common Core. It's a different way of doing it. Does that make sense?
I didn't even know there was a Common Core.
Oh yeah, yeah. It's the trippiest one for me is when people are learning how to count now, and they count by tens instead.
What?
So instead of doing 8 plus 7 and knowing that 8 plus 7 is 15, they'll take 2 from 7, put it to the 8, and make it by tens and count it. I know.
It is
And
like you
that's
have to complete
that,
it before you
and
go.
that's Common Core.
Oh.
I feel like with me, when it came out of Common Core, it wasn't like my teachers taught it. I feel like
Yeah.
I understood Common Core. Like as a kid, math for me was, math and English were one of the easiest things I got growing up.
Mm-hmm.
So I would solve math in different ways, you know, like I like 2 plus 1, well, like, you know, 1 plus 1 plus 1 plus 1 is 4, so 2 plus 2 equals 2. You know, so like, it was like different things that would kind of make me think about it. But my teachers like I remember doing one problem, and I did it one way that was still Common Core, but they were like, no, you have to do it this way.
Yeah.
And I think that was my issue, having to do it this way.
So
You know.
I'm so glad you brought that up. The problem with Common Core is not Common Core. The problem with Common Core is elementary school teachers don't have to know math, which is hard because elementary school teachers have to know everything to teach the elementary school kids, right? But I feel like math is kind of important, but I don't know how you fix that problem. You make the elementary school teachers have to know math?
I know how they fix it. They give you a big worksheet full of multiplication problems, and they make you take it in 1 minute.
I used to hate that.
I used to love it because that would be the only one in
Everyone be like, what?
I got a,
All right.
I got a trip to McDonald's because of it.
So, check this out. You ready for this? Did you notice that the first one is way the heck up here?
Your screen is probably.
Way the heck up here.
Oh, I didn't know.
Now here's the part that's trippy. Your trapezoids are not going to be the same heights anymore. I don't know if you can see it,
Yeah.
because the next one happens at 4. So that's 1, 2, 3. Here's 4. 4 goes up to 1, 2, 3, 4, which is right here. So this first trapezoid is this shape right there, which has a width, by the way, of what? What's this delta x from here to here? 3. 3 has a width of 3. Yes?
Yeah.
Now here's the trippy part. Where's the next interval?
From 4 to 4.
From 4 to 4?
I mean,
4 to 5. So that's going to be here at 4, goes up this high, and then up 5. 5 goes up to what?
3.
Here's the next trapezoid. Now, what's that interval from 4 to 5?
1.
So, when you do this area of this trapezoid, yeah, the first one is going to be this one in blue, which is going to be, would you agree? It's just going to be, let me scroll that up a little bit here. That's just going to be 1/2 times 12 plus 4 times 3. Does that make sense or no? 12 is up here, 4 is right there. Yes? Those are your bases. How'd I get the 3? How'd I get the 3? Yeah, your delta x is how much it's changing from one to the next, which is changing by 3. Yeah? Help me with the red one. The red one's going to be 1/2. What's those values? 4
4 plus 3
plus 3
times 1.
times 1. Okay? Now again, when I did this, I kid you not, I would draw this whole thing out. But once you start realizing it, you don't have to anymore. But drawing it was something that helped me. The next one I'm going to do in orange. That's too close to red. The next one I'm going to do in pink.
Like right next to orange.
Next one I'm going to do is purple. Let's do purple. Purple's good. Purple, right? Where does purple start? So blue went from here to here. Red went from here to here. Where's purple going? There to there, yes? So it's going to start here at 3, right? At 5, I mean. It goes up to 3. And then goes to, what's the next number? 6 and 2, which is right there. What's that width from here to here? 1. So what am I going to add?
1/2 plus
3
3
plus 2
times 1.
times 1 again. We just keep going. Next one, let's do green from here to here. So that would be from 6 to 8 now, won't it? 8 goes up to what? Boom, like that. That's another trapezoid. That's going to be plus 1/2, 2 plus 1 times 2. We're almost done. Okay, now we'll do pink. Pink goes all the way up to 11, 8, 9, 10, 11, which is right here, and it goes up to 2, which is up there. Connect that right there like this. And that last one's going to give me plus 1/2 times 1 plus 2 times, what's that? 3. This whole thing that I have written out is the approximation of the integral from 1 to 11 of my function.
That's a lot.
It is. Now again, do you need to write all this out? Not really, but it makes it easier for you. I know it's tedious, but the math isn't that hard. The concept is the part that's hard. You need to understand. Now, some of you are like, concept's not that bad, but it kind of is. It kind of is. Well, maybe not for you, but for me, you know what used to trip me up the most? These numbers right here. Because when I was taught this, I thought all delta x's should be equal. Because when I made you do RRAM, LRAM, and MRAM, I made you have the delta x's be equal. You remember that? It was always like 0.5, or it was always 1. It was always something that was nice and it would make nice little slices. Then you take the AP exam, sometimes they don't do that. They give you these weird slices. And you realize they're all the same. See, how did I get this 3, by the way? This right here, this with the 3. You can kind of see it by drawing it out, yes? But if you look at the table, count it from here to here. That's a 3. You see it? How did I get this 1 right here? You can look at it here, or you can count it from here to here. You see how that's a 1? And you can do that for all of them. Check this out. What's this one count? From 5 to 6, how much does that change by? 1. How much does it change from 6 to 8? How much does it change from 8 to 11?
3.
Those numbers that are up at the top there are the numbers that I have as my delta x's down there. Do you see it? Anita, I saw your hand up. What was up?
There's a shortcut.
Yeah? What do you see?
6, right on the table if you look at it. They're going like in a pattern like this and they start flat line. So it's like 12 times 4 and then minus 4 minus 1 and it's 2. Maybe 4 plus 3 and then minus 8 and 4 straight. And you get the same thing that was there.
Say that one more time. Start off slowly.
You do 1/2 and then I did 12 plus 4 because it's like that. And then I minus 4 minus 1 on the top. And then I do 4 plus 3.
Hold on. Minus 4 minus 1.
No, it's like like you look at the way the graphs move
Uh-huh.
and then you follow them.
So,
Because you see the like the graph, right? It's going down and it's going flat.
yeah.
It's doing the same thing on the graph. On the table.
Yeah.
Okay, never mind.
But that's, what if the table had different numbers?
Then you do something different.
Yeah. So here's the thing. Patterns are nice, but we got to make sure the patterns can be applied to every single table, right? Every single problem. The only pattern that, you know what? I like that though. You're seeing it decreasing by 1, and then it doesn't. You're kind of like estimating what the function's going to be, I think. In this case, I think the function's almost quadratic. Not quite though, but it looks like it. I don't actually know though. Now here's the thing. You can sit there, try to figure it out, but if they're just asking us to calculate the area, you can just stop there. But no, that's a good pattern to observe. Oh, by the way, if you want to get the final answer for this, I believe the final answer for this is going to be, let's do this real quick. That's going to be 24 plus 3.5 plus, or 7 over 2, yeah. 2.5 or 5 over 2. 3, is that 3? And 4.5 or 9, wait, yeah, 9 over 2. No one saw that. This thing is approximately 37.5. If they all had it, yeah. So in this case, I couldn't do that technique of factoring it all out. So there's no real shortcut for this one since the delta x's are different for each one. If you really wanted to, though, do this on your calculator without typing this all out, there is a quick, slight pattern.
I really don't want to erase this.
You just do like 12 plus 4 times 1. Okay. Anyways, you okay? Looks nice. How's it? You okay with trapezoid rule? Honestly, I should have showed you trapezoid rule before we did the integral, because now you're kind of like, I know how to do integrals now. I don't need to do these approximations. Because with the integral, you can just do the antiderivative, plug it in, you got your answer. The problem is they're not always going to give you a function. Yeah. All right, let me, here, you guys try this one on your own. You ready? You do not need to draw a picture for me. You just got to give me the answer for this one. Okay? So let's go for what? What do you need? 4 minutes. Try it. You do not need to copy it.
Oh wait, there's not that many numbers.
I know. You do not need to copy it. Just the table.
Yeah, I feel like if I go back, it won't make sense if I don't copy it.
Copy it, then at least copy the table, and then copy this part down right here, because that's what you're trying to find. So try this out. See what you get.
Have you gone to see Batman yet?
Nope.
That's the way. That's.
I usually just ask.
Oh, I didn't hear.
I said that.
It was a little bit ago.
Are you going to?
Yeah. Just like, you know, eventually I watched Venom.
I still haven't seen it.
Hey, not
Me
me.
either. I
You
don't.
still haven't watched Batman either, huh?
No.
Oh my
Not I
god.
went at 11 and I came out of the movie at 2 in the morning. That movie is way too long.
To actually go by to 21.
I haven't watched.
You don't have to draw it.
It's worth it.
Dude.
They moved with the
Go
prices
back
though.
to your table method.
But then I need to.
Go back to my.
Switch it to the table.
There's no way.
What table? This table?
Yeah.
There's like no way.
I really do not feel like
It's a very
doing
gay.
the debate.
Great.
So I'm just gonna copy that.
Luca? Have you watched Luca?
It's so
No.
Yes,
It's
so
so
cute.
queer coded. There's no way it's not queer coded.
Not pre-coded?
Queer coded.
Queer coated.
Queer.
Oh, queer code. I said pre-coded.
Not this again.
No, Luca.
I'm gonna shut up.
Well, maybe, yeah. You can see it.
And like,
I went on TikTok and they were talking about it and all this other stuff like Luca and what's his face? Oh, is his name Alberto? Whatever. his
I haven't
name is.
watched it yet.
Yeah, Alfredo.
That they were. I was like, no, I'm done.
And, like, it's obviously queer coded. When you watch the movie, it's very obvious. Like even my parents figured it out. Like that's how
I
like
didn't
queer
see
coded
it.
is.
So why wouldn't they just blatantly? Oh,
You should
because
watch it
Disney,
and let
there's
me
lots of
know.
controversy. They probably not get as much money.
Yeah.
I'll watch it later.
Yes, watch it and let us know that
It's
means.
really good.
I've never
Watch
seen
it.
You know what I thought was like surprisingly good? That was like accepting of all was Steven Universe.
I love that show.
Okay.
It's a very good
I was
cartoon.
expecting this.
No, not a movie. This is a TV show.
I hardly watch
Have you seen it?
No.
You ever watched it?
No.
You should watch
hardly
it.
watch Steven
Is
Universe.
it like
So the first like 12 episodes, like just like they're short episodes that just like, oh, hey, this is this kid who's going on an adventure with these weird gems, and it's like doesn't seem like there's much of a story,
It's good.
but it develops really well. Like all the characters have,
Especially season 5.
yeah,
Oh
all of
my
them, all the characters develop really well, and then like the overall story is just amazing. So
The fusions are great.
have you watched The Good Place?
no,
I feel like you would like The Good Place.
season. Yeah, it's pretty good. I didn't watch the past season.
you gotta watch the rest of it.
It
It's-
just
it-
develops.
Oh, the good place. I mean.
Oh,
You should watch it. The ending is sad. I
wait,
cried.
what's the good place?
watch it then? So it's about this lady.
It's
Wait, is it
about-
cartoon or?
No, it's like a sitcom.
Oh, on Channel 4. The Heaven one.
Yeah.
Yeah. I couldn't get into it.
What?
My girlfriend watched that all the way through, and she's like, "You would like this." And I watched the
You-
first season, and I could not get into it.
It gets better. No, it doesn't get better. It just
Sometimes.
you get more invested in the characters the more you watch it, and like the more you watch it, you want them to succeed.
You know what?
She describes every show
I
she
think
watches.
so. There was that show that people really like, and then the other show that they liked was Community.
Oh, I love Community.
See,
Up
that's
until season
that.
4.
See, that's another show I couldn't get into.
Do I have to do the whole graph?
No, you do not need to graph it. I just want the answer.
Yeah.
Okay.
You do not need to graph it.
Because I was about to start graphing it.
You do not need to graph it. Just give me the answer.
I can so
Oh.
basically,
You would like
it's literally
Community.
just
I've watched it.
it's literally just one half this was this but this minus that. That's basically it. I don't want to plug all this in. Now you're just bothering me.
Okay, this is what I have so far.
Oh,
What's the height?
Jasmine, did you turn in your coat?
I just
Right
saw
now.
it's always
Because I honestly don't even know what order I want
I
to
put bullshit. Wait, I put bull crap.
Did you recording it?
A Marvel quote.
Yes.
What?
So someone put with
No, wait! Can I change it?
Yeah.
Yeah.
Actually, I know what I want to put. NJ's quote. That's like my favorite quote.
Oh my God. Yes.
Oh, but it has to be something one less. I'll shorten it. Expect when you
Yeah,
expect
Expect
disappointment,
disappointment and you will never be. Expect disappointment and you will never be.
Smaller. But I like the
Expect disappointment
third.
and you
I
will
like the
never
little
be
hash.
disappointed.
recording?
Yes.
People are
Hello.
usually 9, 10 years old. I'm 11, so shut the
It's a recording, so they're not gonna say hello back. That's how recordings work.
Oh, how the heck?
I'm very upset.
You have a hole?
No, I have a stain.
Oh my god, it's the end of the world.
It is.
It could be washed.
Yeah, I mean it is gonna get washed, but I have to walk through the whole day with the stain here.
It's so like invisible.
No.
Not to me.
They just turn and just like walk like looking at this side.
You know what? Sorry to bother you.
Just put like a little band-aid over it.
I'm hoping that this answer is correct.
No, it wouldn't be like
What'd you get?
Is it? I'm stuck on the last. What did you?
Let's see if I got this right. I don't know. Watch it be terribly wrong. I would
Yeah, okay.
Are you done?
I told
I just
told
wanted
you
to
it was
make
half.
sure.
No, it's.
If you're gonna do the shortcut version, which you can't. Well, you can actually. No. You're gonna do it like that. That works fine.
I want that to be my senior quote too. That's my
Do
favorite
the same.
quote of all time.
You can do it with one half.
Me too.
That's literally my mindset.
Yeah.
Mine was just like failure. While hard to
Well, one half and you need to take multiply everything by
What was it?
correct it.
failure, while hard to bear, is an indicator of improvement.
Okay, but now we.
One half on each of them? What she's doing is she's factoring them all out in front and then putting a gigantic parentheses around
There you go.
this is our.
I had to take out one word because it was 11.
So
And then
we can't.
also.
We can't. Wait. Okay, we can't use this. I thought we already used the 7.
No.
Oh, we used it twice.
Jasmine, do you want to write your quote here?
Well, sitting up for your one. Give me like 5 minutes.
He understands.
I was like, oh, I thought she was confused. No, she's just like, okay. Accept that.
I had mine right.
Okay. What'd you get?
Oh.
What'd you get?
Are you still just copying on the words?
It's all over there. Akmi, can you pick up our pen?
No, Esther.
Let me see here.
The strawberry milk
I don't.
warm.
I would double check. Did you do one half of this? Yeah, double check that back.
Okay.
Sorry, that right.
Esther.
Hold on.
Sorry.
I'm doing my math right.
No, strawberry honestly. Like any
People, a lot of people hate on strawberry milk.
I know. Like her.
No, I just find it like if I drink too much, like mixed in, like too much of it, I can't. And that's the goes for
It
anything.
makes sense. A lot of people hate on it. Like, ew, strawberry milk. I'm like.
What'd you get for the first trapezoid?
21 plus 11.
No, give me the number.
Oh,
Do it like that.
32. The second one.
36.
Last one.
16.
Check the last one.
Are you
Alright.
gonna watch
You're
Morbius?
right.
What?
Morbius?
Eventually.
I don't know if I want to go watch it when it comes out or not because it
Oh,
just,
so it's
it's
two.
just kind of
It's two.
boring.
That's
86. 86.
What's 64 plus 72?
Okay.
Number probably?
I didn't answer it.
So-
Hold on, I'm
You
so
actually gonna draw it out? Like, I think we all know how to.
I'm gonna show you my shortcut of drawing things.
Oh, okay.
Do you like tacos?
Yeah.
What kind? If you say from Taco Bell.
Yeah, authentic Taco Bell food is very authentic, right?
Taco Bell.
Al Pastor is probably my favorite.
I got it.
Al Pastor is probably my favorite. And then in my older years, I started liking cabeza and lengua.
Lengua.
I've never had it.
But none of that,
Mango's a classic.
none of that will ever top a classic Taco Bell gordita. No, but yeah, what's up?
Do you like
No, we're talking about
Huh?
thousands of
It's okay. It's okay. I wouldn't like turn it away. I would eat it.
We were talking about
I go the harder way.
bread.
So that's
Shh. All right, guys. So it looks like most of you guys got the answers, but here's the thing. Hey.
Listen.
So when you're drawing it out, I know that like 21 sounds ridiculous because you're gonna make like 21 tick marks. Just do what I do and just say, yo, you know what, that looks like 21. You know, and just estimate it. There's no harm in just estimating what you think it's going to look like.
The little lines on the y-axis.
Boom, right there. Yeah, and just say, yo, that's 21. It's not. Oh, it's not drawn to scale. And then you do the same thing for 11. So you see that first one right there is gonna be 1/2 21 plus 11. That 21 looks like a 4. Times, what's the gap from here to here? That's just a jump of 2. Yeah? And you just do that for all of them. Okay? So this next one would be plus 1/2. 11 plus 7 times this gap from 5 to 9, which is just 4, plus the last one, which is going to be 7, 1/2, 7, and 2. 7 plus 2 times that gap. What's the gap from 9 to 13? 4, right? So that's the setup right there. Some of you guys have gotten a little bit more adamant with finding shortcuts, which is fine. You can do it like by writing the 1/2 in front because they all have a 1/2. Calculating this all out, this first one is going to come out to be 32. This next one over here is going to be 36. And the last one over here will be 18.
Hey, I did the same thing.
So you get the total of
86.
86. Ta-da! 86. How do you feel?
Good.
I feel like
Honestly, I feel glad that I got the answer.
Good. You should.
I eventually
You say bad?
Good.
Oh.
Yeah,
I heard bad too. I was like, AJ.
Nothing. What's your favorite color?
Glad that I got the answer.
I say nothing like black. That's the thing.
Blue.
What kind
Kind
of
of
blue?
blue.
Dark.
basic.
Like
so
navy blue?
Navy blue?
Royal blue?
Oh.
I was gonna say something.
That,
See,
okay.
navy blue has been my favorite color since like first grade.
Nothing.
I thought it was black.
It's the, ish. It's the color I used to dye my hair.
You used to dye your hair?
Dark blue.
What?
is
Oh
so
my
easy.
I'll show you eventually.
Oh, I want to see that.
I need to see that.
What?
Last one I want you to try on your own before I talk to you about, yeah, sure. But here's the thing. What happens if I ask you the same type of problem, but I don't ask you to do trapezoid? What if I ask you to do it using LRAM instead?
Oh, I forgot.
Wait.
People is giving up.
You shouldn't. It's actually just as easy. With your favorite, no fractions. No fractions on this problem. Esther?
Oh.
Ooh, I don't know how to phrase this. Do we have? I don't. Come back to me.
Okay.
So it was.
Go ahead, Steven.
So it's just rectangle.
Yes.
So it's 11 times like the interval and 16 times the interval. So it's
Yeah.
Wait, you don't use 10.
Let's talk about it. And yeah,
do we write it all down now?
I would get you to start solving it. So
Do you want to write it? Want us to write down?
no, you don't need to write down the problem. But I would write it down if you feel like that would help you with your notes.
Probably.
So, again, you see the integral symbol, you should be thinking area underneath the curve, but the problem is I don't know what the function looks like, so I don't know what the curve looks like. But I do know output values, don't I?
Yeah.
So, I don't know what f of x looks like, but I do know the dots. You ready? So at 4, it goes up to 11, it looks like. So 4, 11 is like right there, right?
411 is this.
Yeah, I was gonna say.
And we go to 8. 8 goes up to 16, which is like right about there. 9 is like right next to it. 9 goes all the way up to 21, which is all the way up there. And then 10 is right next to that, which goes all the way up to 26, which is all the way up there. Something like this, yeah? But they want us to calculate it using not trapezoid rule, but Riemann sum, but with the left side. So can you picture the rectangles that are being made on this graph? Can you picture the first rectangle? How high up does it go?
It goes
Does it go up here on the 8 or does it go up here on the...
4.
Why on the 4?
Because that's where this starts. on
Yeah,
the
it's the left side. It's only on the left side. I heard that's the crypt side.
What?
All right.
Knock me.
Mr. Knock Me.
What is going on with you?
It's not even. It's 8 days. It's only been 8 days.
You've been holding that
Wait,
in
it's
for a
a-
long
it's-
time.
Wait, it's a song.
Okay.
You never heard Snoop Dogg say it?
I've heard of Snoop Dogg.
He did it in this.
You've never heard of Snoop Dogg?
Yeah, only on the left side. Yeah, that's the crypt side.
West side.
No, left side.
Anyway.
Pretty sure it's west side.
Left side.
It's left
I
side.
would think it's west side.
Let's go.
But okay.
Just look it up.
Move on.
You know, she was so surprised that I could listen to hip hop. It's frustrating that she thinks that.
She's always like,
Stop. Lila,
You listen
stop.
to
I
K-pop?
don't just listen
Go
to
back to the
K-pop.
Wait,
So, check it out. They say 3 intervals. It's a fancy way of saying 3 rectangles. You see the 3 rectangles that came up?
Yeah.
I don't even use the 10 and the 26 on this one, would I?
Nope.
I would use that though if it was RRAM. Yeah, this is LRAM. So I'm just using all the left values here. Kind of easy to see now, right? I'm telling you, when you come across these problems where they ask you to find integrals and they only give you like a table, I really, really suggest you start drawing it out. Do you need to? No, not at all. But it makes it easier to see. Does that make sense? So, how do I get this? How do I get this? How do I get this? Well, all you gotta do is multiply them all out, yeah? Check this out, check this out. You ready? What's the height of this rectangle over here?
And 4.
11. And the delta x from here to here? 4. So what's the area of this blue one? Bam!
Okay.
Let's keep going, let's keep going. What's about this dot right here? How high is this one going up to? 16.
16.
What's...
It's 16.
Why is it 16?
Because it's 16 times 1.
Wait, no, not the area. Why is the height 16? The table tells us that. And then the width of this is 1, so this area is 16, because 16 times 1.
Yes.
And the last one, 21. What's the base? 1 as well, so this is also. So that's pretty much it, right?
That's so cool.
So if you wanted to show this work, it's technically 11 times 4 plus 16 times 1 plus, what's the last one there? 21 times 1. So AJ, it's exactly like what we've been doing, except we don't have to add 2 things or divide by 2. You see it? Why am I not dividing by 2?
Because it's not trapezoid.
It's not a trapezoid, it's just a rectangle. So it's just base times height. Base times height.
You can just make a
Base times height.
trapezoid on there.
Base times height. Out of the 4 intervals, I'm sorry, 4 values here, I can only make 3 rectangles.
It's so funny because I was like this.
3 subintervals.
See, the way that I see it is like,
Hallelujah.
okay, 1 to 8, that's like 4. You multiply that with the down. And then you do the same thing and multiply with the down. I don't see it as that. I see it as the.
But you
up,
realize that
down.
what you're saying is the same thing.
Yeah.
What you're saying is the same thing though, right?
Yeah.
Yeah. Which, it's fine if you see it that way. It's the same thing as what I'm saying. So if you see it that way, it's still the right answer. Does that make sense? What's my answer, by the way? 81. Now, if I had switched it up on you and said, yo, can you tell me the RRAM of this?
It'd just be 16 times 1 plus 21 times 1 plus 22 times 2 or 23 times 2.
Something like that.
21 and 26.
It would be these rectangles here, would it not? So the first one would be 26 times 1, 21 times 1, and 16 times 4. And that would be your RRAM. So you got RRAM, LRAM, and you got the trapezoid rule. Pretty nailed down, right? It's not that bad. Would you agree? See, it's doable, yeah? That means that there's one that we're skipping, isn't there? Mid-RAM, or MRAM, mid-RAM. MRAM was difficult for me. All this stuff was difficult for me if you think about it, but it's easier once you practice. Now, it's only because I'm old. I've been doing this for so long, it just seems easy, but here's the last one. You don't have to turn this, or you don't have to do this in class right now. I just wanted to show it to you. This one is different. So this one was LRAM and RRAM, right? It didn't even ask for RRAM. I just want to show you RRAM's the same thing. You just look at the right side, right? And you just use the formula for a rectangle. Easier than a trapezoid. Yeah? But when they ask for mid or the MRAM, that's not mid. Yeah. MRAM, and that's not enough numbers. Let's say I gave you a little bit more numbers. Yeah, so don't write this down. I just wanted to share with you.
Oh.
Oh, I want to write it down.
We're not gonna do it like next class.
Well, you can, but I wouldn't.
I'm writing it down.
Okay, so,
Are we done then?
well, I need to show you
No,
this
but
still.
we need to-
Yeah, no. So,
Yeah, I'm third.
if you're looking at this one and you're looking at mid-RAM, you don't do side by side anymore, because if you do side by side like this, what's the value that's between 3 and 5? You'll say 4, yeah, and that's not wrong. But what's the output value for 4? You don't know that. You don't know if the middle output value is going to shoot way high or shoot way low, because I don't know what the function is doing. Does that make sense? So I can't just assume what the f of 4 is going to be. That's a bad assumption, because I don't know what it is. So if that's the case and you're doing MRAM, guess what you should do instead? Use this as your MRAM.
Oh, and 5.
And guess what's in the middle? Yeah. So we're going to use that as your height. So,
13.
your first rectangle is going to go from 3 to 9 and has a height of 11. You see it? So I don't care what the 3 is. I don't care what the 9 is. I just care the height at the middle of it. And that right there, this 5, 11, will give me this area. You see that? And you do it again for the next rectangle, which would be from here to here. Or actually, I guess you could do from 9 to 15. You see that? But I don't think that's exactly in the middle, is it? Actually, no, I would not do that. Actually, I would. Yeah, so I could do 9 to 15, whatever that is, and it'll be that 2. It's not, 13 is not exactly in the middle, but it's close enough to it. Does that make sense? It's still in the middle of it, and I have a value for it. Does that make sense?
Yeah.
So at 13 and 15, it's off by like a couple bit, but that's okay. I can estimate that with that one. Does that make sense? And you do the one last one, which will be 13 to 19. No, that's a lie. I need another number. 15 to whatever that is. Does that make sense? I just made up this problem. I just realized that, and it's not going to fit right. That's why you didn't copy it down. But that's it for today. And that's it with 5.4.
That's our
Wow.
that's 5.4.
That's it.
And now we have a test next week.
Now you have a test on Thursday.
Wait, what?
You know he's playing games.
Not playing games. You have a test on Thursday.
You're playing games.
This Thursday?
You have no study guide for it.
Oh, okay.
You have no study guide for it.
Not
I will
me.
put up the homework for you today for 5.4.
I will sue you.
And you have a test on Thursday.
I will sue you.
Not me.
No,
Are you
please
serious
don't.
right now? Why
So-
can't it be on Tuesday?
So come in ready.
Thursday.